Hi guys, we're ready to start solving exponential and logarithmic equations. You'll actually have already done a tiny little bit of that in the first lessons, but now we're going to look at specific strategies on how to do it. The strategies that the textbook provides are: you can rewrite the original equation in a form that allows the use of the one-to-one properties of exponential or logarithmic functions. What that really means is that we are going to look for same basis. And then you can read the next two properties. They're in terms of rewriting your expression. The way that I say it is whenever you're stuck in an exponential, convert to logarithmic. And whenever you're stuck in a logarithm, you want to convert to an exponential. Let's go ahead and look at a few specific examples. For problem A, we have 4 to the x is equal to 64. Let's try to rewrite this with the same basis. We have 4 to the x is equal to, I do believe that I can rewrite 64 as a power of 4. That will be 4 to the third power. Whenever you have the same basis, the only way that these two quantities are equal to one another is if and only if the exponents are equal. The way that most students tend to say is that you can eliminate the base and just set the exponents to equal to one another. We get that x is equal to 3. Let's look at the next one. Natural log of 5 minus natural log of x is equal to 0. Once again, we have the same natural log, which means both of these logarithms have the same base. I'm going to start by adding natural log of x to both sides. That gives me that the natural log of 5 is equal to the natural log of x. The only way that this would be true is if 5 was equal to x. Now, one thing that you have to be careful with, whenever you're solving logarithmic equations, you have to check your answer. I want you to please add this little note to your notes. Whenever you're solving a logarithmic equation, check your answer. The argument of the logarithm must be greater than 0. In our case, we have an x inside of a logarithm. Our condition is that x must be greater than 0. Well, the answer that we found is indeed greater than 0, so yes, this here is a valid answer. Let's look at example C. 1/5 to the x power is equal to 125. We need to rewrite this expression, and it looks like both of those might be powers of 5. So we're going to try and change the base to be equal to 5 on both sides. 1/5 is equal to 5 to the negative first power, and the whole expression is to the x power. 125 on the other side is equal to 5 cubed. Before I can set the exponents to equal to one another, I need to apply the rule for exponents here. I have power of a power, which means I need to multiply these two values together. -1 times x gives me -x. So we have 5 to the negative x is equal to 5 cubed. Now I am allowed to drop those bases. We get that -x is equal to 3, or x is equal to -3. Now note for here, I am allowed to have a negative exponent, so I don't have to worry about checking it. In case that you want to double check your work, absolutely, you can input in the calculator 1/5 quantity to the negative third power and make sure that it does indeed give you 125. In our next example, D, we have that e to the x is equal to 13. Once again, e is that irrational number that continues forever and ever. Its approximate value is about 2.78. There's no way that I know what is the power on 2.78 something that will give me 13? It looks like I'm stuck. I don't know what the answer is. Whenever you're stuck in an exponential, convert to logarithmic form. The easy logarithmic form to convert to, oh, actually, we're just going to do it in that format. We are going to take the exponent out and set it to equal to a logarithm. That equals to log base e of 13. And yes, some of you probably caught that if you have the logarithm with base e, you really will be writing the natural log of 13 is equal to x. You can absolutely input this natural log of 13 in your calculator and see what is the approximate value for it. At the same time, we can also leave the answer just like that. If that was a question on a test and it gave you decimal representation, then go ahead and put it in a calculator. For here, this is a perfectly fine answer. Let's look at the next example. We have that the natural log of x is equal to -8. I am given a logarithmic function, and I have no idea what is e, that invisible base that I don't see, to the -8 power. What I can do, if I'm stuck in a logarithm, is convert to exponential. That is the same as saying e to the -8th power is equal to x. Now, remember that whenever you have a logarithmic equation, you have to check your answer. Is it true that e to the -8 is greater than 0? Yes, absolutely, because it is equivalent to the reciprocal of e to the 8th. And even though I might not know its exact value, it will be greater than 0. Sorry for that little interruption in my classroom. Our answer is e to the -8. And we did check that it is indeed greater than 0. For the next problem, we have e to the -x squared is equal to e to the 5x plus 6. We do have the same basis, so just like before, we are allowed to drop those bases. The only way that these would be equal to one another is if their exponents were equal. -x squared is equal to 5x plus 6. Now we need to solve that quadratic equation. I might need to add x squared to both sides. We get x squared plus 5x plus 6 is equal to 0. We can factor this. It is x plus 2 times x plus 3 equals to 0. So that gives me x is equal to -2 and x is equal to -3. I do have two separate answers because we have a quadratic. If you're not positive whether this was the right answer or not, go back into the original equation and substitute it. See if it really makes sense. Let's look at part F. We have the log base 3 of 5x minus 1 is equal to the log base 3 of x plus 7. Once again, I am easily seeing these same bases. Whenever you have the same basis, you are allowed to just set the arguments to equal to one another. That gives you 5x minus 1 is equal to x plus 7. We can solve that. Let's go ahead and add 1 to both sides. At the same time, we're going to subtract x from both sides. We have that 4x is equal to 8, which gives you that x is equal to 2. Now we're not done. Yes, we did find a value for x, but no, we do not know for a fact that this is a good value. We have to be able to input it in each of the arguments and get a positive answer. For here, it might be easier to just substitute in. 2 times 5 is 10 minus 1. Yes, that is good for this logarithm because it is equal to 9. 2 plus 7 is also equal to 9 here. That works. Both of them are positive. This is a good, valid answer. On the back part, we have 4 times 3 to the x power is equal to 64. Since we want to leave the exponential all by itself, we're going to get started by dividing both sides by 4. That gives us that 3 to the x power is equal to 16. I do not know what is the power of 3 that's going to get me to 16. It looks like I'm stuck, and I am stuck in an exponential. At this point, I'm going to convert it into a logarithmic form. We have log base 3 of 16 is equal to x. A lot of your calculators are not able to put that in, so to be able to evaluate it, you would actually have to use the change of base formula. X is equal to, I'm going to just do log of 16 over the log of 3. Now you can input this in the calculator and see what it is approximately equal to. For the next problem, it looks like the natural log of x is also not all by itself. We are going to get started by solving for this whole thing, ln of x. The first thing that I need to do is subtract 6 from both sides. That gives you 3 natural log of x is equal to 4 minus 6, which is negative 2. Now I have 3 times my log of x, so I need to divide both sides by 3. We get that the natural log of x is equal to negative 2/3. Once again, I have no idea what is the power of e to the negative 2/3. So to be able to find x, since I'm stuck in a logarithmic, I'm going to convert to exponential. That is e to the negative 2/3 power is equal to x. Now this x value, remember, you can just tell me it's an answer. You have to make sure that it is greater than 0. I do have a positive base to any power. Yes, this value will be greater than 0, and it does work. I can input it in the calculator and see exactly how much that is. And then for the last problem, you have the log base 10 of 25x plus the log base 10 of x minus 3 is equal to 3. Well, I have 2 logarithms, and I have another number. It looks like I need to use the properties of logarithms to combine those two together. I will not be typing in or writing the base 10 because this is our common log. But I do know that I can combine these values into one equation by multiplying them. I have log of 25x times x minus 3. All this is inside my logarithm is equal to 3. I can multiply this 25. Honestly, at this point, I am actually going to leave the 25. But nonetheless, it looks like I'm going to be stuck in a logarithm. I need these x's to come out of the logarithm. To come out of a logarithm, I need to convert to exponential. So right here, I can change this into its equivalent exponential, which is 10 to the 3rd power is equal to 25 times x squared minus 3x. I can divide both sides by 25 right here, just to make my life easier. That gives me that 40 is equal to x squared minus 3x. Believe it or not, this quadratic is factorable quite easy. X squared minus 3x minus 40 is equal to 0. This is x minus 8 times x plus 5 is equal to 0. Go ahead and finish writing out the two answers.